Well, that's good. At least you know some other guy. Which other guy? Okay. So the people who invent calculus are Isaac Newton and Limbus. Okay, Limbus is another one. Nobody ever remember that name. Always people is going to be like some other guy. And so make sure you understand the name because he actually make a lot of contribution on implicit derivative. So it's actually very, very valuable. So a lot of time that you have to understand, back in the days, the mathematician, they kind of, most of them are jack of all trade because mathematician is actually very creative. It's so creative they can think about a lot of things. So they can be philosopher, they can be mathematician, they can be musician, they can be inventor, they can be accountant, lawyer. I think Descartes was a lawyer, a politician, or some type of things. So, you know, a lot of times you have to understand back then mathematician can do it all. So what I'm going to do is I'm going to start with calculus with the idea of limits, right? So the calculus start with the limit process. So limit process. And then once you understand the limit process, which is what we did on the first test, and then it's going to lead to the calculus, okay? Now, what happened is calculus is composed of two problems. The first problem is going to be the tangent line problem. The tangent line problem. The second problem is going to call as the area under the curve problem. Area under the curve. So we got these two problems presented. And what does the two problem look like? Well, first of all, what is a tangent line and what is a secant line? Do you guys know the difference between tangent line and secant line? In geometry, you actually learn about tangent line. Nobody tell me what is a tangent line and secant line? Okay. Okay, so tangent line is, we're going to show you secant line first. A secant line is going to be a circle, and it's going to intersect 2 points. So 1 point here, 1 point here. So we're going to call it, this is a secant line. So it intersects 2 points of the functions. 2 point of the functions. Okay. And then tangent line is going to be what? Right, intersect exactly 1 point. Oh, I draw ellipse, so which is fine. 1 point, which is gonna be look like, gonna be like if I have a point, and it's gonna be this point, and tangent line is gonna be like this. So that's only intersect 1 point. So this is called a tangent line. So tangent line, it intersect only 1 point, like 1 point. Okay, so intersect 1 point and the secant line is 2 points. Then what if I want to find out slope of that point? So slope of the tangent, that becomes a big problem. So slope of tangent to the curve. Or could be the functions. So for example, today we're going to investigate something like this. If a straight line is easy, straight line, just take any point, just see the right overrun. But in this case, it doesn't work like that because we're talking about a curvy line. So we look at this functions, which is y equal to x squared functions. It's going to look like this. And we look at this point. What is slope of that point? First of all, that's not a very good graph, so I'm going to change that. And what is the point of this? This is actually a really, really accurate graph, by the way. So this is a tangent line at a point. How do I figure out what is slope at that point? Are we okay here so far? Well, really, that can change, right? Depends on the location of that. So sometimes slope is going to become steeper, sometimes it's going to be flatter. It really depends on what the x value we're talking about. So that's very, very important. So that's going to be slope of tangent line. So this is a question mark. That's a big question that looming around for 100 years in between, it could be from 1500 to all the way to 1650 or 1655, 1660, where Newton and Leibniz kind of figure out a way to do this. And then Descartes says, do you guys know who Descartes is? Rene Descartes? He's a philosopher. What did he say, like usually? He have a famous quote. Nobody can tell me. Okay, I think, therefore I am. Have you heard that? He's a famous mathematician. He says, I think, therefore I am. So that's a way that I think about Descartes is he's very, very well known. He's actually very religious, by the way. Very religious accountant or lawyer. I don't remember what his profession is, but he was a really good mathematician besides being a philosopher. Then what is the second problem? The second problem is the area under the curve problem. And we're going to talk about that the second half of the year. So we're going to know, you're going to use the x-square graph again. And that is the x-square graph. And then what will be the area of this between the curve and the x-axis? Okay, will be the, and if you pay attention, if you zoom in enough, they're not exactly rectangle, they're not exactly triangle, they're not exactly everything. They are kind of along the curve, and what will be the area underneath? And that's the biggest problem for students, is to figure out what that is. Are we okay here so far? So that really, geometry doesn't take care of that. Either case, geometry doesn't take care of it. Geometry cannot find out slope at any given point. Geometry cannot find out the area under the curve. So then, next after geometry, there is a pre-calculus, which is you learn about limit process. And then algebra 2, which is all the way algebraic work. And then lastly, says, well, maybe we need a calculus to solve this issue. So Newton and Leibniz says, wait a minute. We can use algebra still. Algebra is going to be very, very effective, but we just implement algebra with some arbitrary things that we can construct. So what we can do is we can construct a scenario. This scenario is going to be something like this. And we're going to draw a parabola to this point and this point. So we're going to say there was some type of parabola going to here, like this. And this is arbitrary. This scale is different. Arbitrary means I can arrange this x at any value. It does not happen to be 5. Could be 10. Could be 100. Could be 1,000. The x is just an arbitrary number, which is x is a variable. So it could be any number. Are we okay here? And we're going to have a h to the next point, which this h is going to be from here to here. My bad. The h is going to be from here to here, and we're going to call this distance h. Okay. So let's name a coordinate. We're going to call this function f of x. What do you think this coordinate, what do you think the output is?
Please release your students for B.
If this is x, what is this name? Y, but y also known as what? F of x, good. So it'll be f of x. Does that make sense? So this coordinate is going to be called x comma f of x. Am I going too fast? So there's a name. First of all, label the name. Second one, second point. What do you think this new x value we're going to name it as?
F of x plus h.
What is it?
F of x plus h.
Well, it's not f of x plus h, just x plus h. So this one is a new one, so it'll be x plus h because we adding the h on top of it, right? And like he says, this part is going to be f of x plus h. So then I'm going to start with this interesting secant line. Okay, so this secant line here, we can find the slope of the secant line. How do we find the slope of secant line? M, we're going to call it secant, and we're going to go deeper, go back to algebra 1. How do you find the slope in algebra 1? Yes. So see us like, yeah, they kind of drill me on those SAT practice, right? Right? Yeah, so that's like, it just become an automatic, which is changing y over changing x, which is rise over run. Then I'm going to equal to in this case, we have new coordinate, right? We have this coordinate as f of x plus h. No, sorry, it's x plus h. X plus h, comma of f of x plus h. Okay. So we got two coordinates. We got the red coordinate and we got a blue coordinate, and we can call this one the x2, x1, y1, y2. And this one is the x1, y1. So with that, I can use that as a point. So it'll be f. So it'll be f of x plus h minus f of x over x plus h minus x. Does that make sense? It makes sense? Anything I can simplify here?
Yeah, x minus x.
Yep. So it'll be x plus h minus f of x over h. And you learn this in pre-calc, whether it's through virtual school or with anything else, with Mr. Craig or Mr. whatever. This one's going to be m of secant. But then you say, Mr. Ed, I thought you want to look for the tangent line. Yes, I'm looking for tangent line. So which line I'm looking for? I'm looking for this black line right here that intersect this point. I'm looking for the slope of this point right here. Okay. And this is the slope I'm looking for. How am I going to find that slope? Then you say, okay, well, I know this h. H is what creates those 2 points, right? What if I can somehow use a limit, reduce that h to 0? If I reduce that h to 0, what will happen? I want to get you a computer and turn it on and get it out. I will show you in a second. So just get a computer out so that way you can see it. So h, let's change that h from 3 to 2 to 1 to 0. So I'm going to change it to maybe 2.5 here. And I'm going to draw a secant line based on those 2 points. Okay. And I'm going to draw a halfway. I'm going to secant line based on those 2 points. Does that make sense? And eventually, secant line is going to be so close to 0, it's going to be almost like a black line. So you see this h, right? You see this distance h is 3 units. I'm going to change into 2 units. I'm going to change into 1 units. So that means my h is slowly decreasing from 3 to 2 to 1 to half to 0.1 to 0.01. And eventually, you're going to get to down to that one single point, and I can find out the approximation of slope. But h cannot be 0. Why h cannot be 0? What happens if h equal to 0? I'm going to have f of x minus f of x, which is 0 over 0, which is indeterminate. So if it's indeterminate, I cannot find the slope. So, but we can use the limit process using h and slowly shrinking down from both directions and to see what happens. Now, you're going to say, okay, well, I'm going to show you on decimal because my graph is a trash. And this is a graph on the thing. So we start with the x squared, and we say we want to find out what happens slope by 1. So we're going to enter 1. So how do you get to here? I'm going to go to here. You're going to go into decimals. So go into the website decimals. And really learn how to play with this, because it's really cool. I think this is what makes teaching calculus at this generation is going to be different than prior generation, because the decimal, what decimal can do. Then what you're going to do is you're going to go calculus. And then you're going to go to the one that says secant line. Do you see that? Do you see calculus secant line? Do you see that? And you're going to click on it. You're going to show up like this. I don't like sine function, so I'm going to change that function to x squared. Do you guys get to that part? Okay. Now what happened is I'm going to change it a to 1. And I'm going to change it to h to 3. Okay. And it's going to look like this. Now also, what do you see? Do you see the m equal to 5? Do you see that m equal to 5? That is the slope. Why is that slope? M is equal to f of a plus h minus f of a over h. The a start at 1. But what we're going to do is, don't change the 1, right? 1 stay the same, okay? You actually changing the 3. Okay, changing the 3 to 2 to 1. Idea is like this. A lot of time, like, you guys don't know how to use chopstick, and you're either white or black or whatever race you are. The problem is people misunderstand chopstick. I mean, Trevor probably used chopstick, and Jackie knows how to use chopstick. Shang, you just probably don't know how to use chopstick. I'm assuming, I don't know. Maybe a good stereotype thinking. The idea of using chopstick is those people know how to use chopstick is one chopstick is not moving. You're not trying to move 2 chopsticks at the same time. So this is how do you use chopstick. One of them is stationary and the other one moves. Okay, so this is how to use chopstick properly. So ideally, I'm not changing the 1. 1 stay the same. I'm just changing the 3. And to get closer and closer and closer and closer, down to 2, down to 1. And you see that slope is changing, right? You see this 2 point that's here? I'm going to change the 3 to maybe 3 to 2.5. What do you see? The slope changing from 5 to 4.5. Do you see that? And you see that line, it was a secant line still. And I'm just going to keep on going to 2. And I see my slope change to 4. Because it's less steep than before. Does that make sense? But the problem is still a secant line. Then I'm going to change to 2 to maybe 1. And you say, well, is that a tangent line? It looks almost like a tangent line, but it's not. Look at it here, right? Still intersect 2 points. Does that make sense? And then we're going to go h is going to slowly decrease to 0.3. Is that a tangent line? No, it still intersect 2 points, right? So we say, well, what happened if I change into, let's say, 0.01 here? And we say, is that tangent line? Well, not really. If you look at detail, see the line is still split, right? So what we can do is keep on going down to maybe 0.01, 0.001, and you see that slope. It's pretty good. See, like here you can pretty much say that's almost equivalent. You don't see the split between two lines anymore. So then you say my slope is 2. And I find out the slope is equal to 2. At x equal to 1. But what's most powerful is this. You not only find the slope at 1, you find out slope at any moment. What I'm going to do is, now my h is going to be 0.00001, so my small change is going to be 0.001. Now I'm going to change my a value. I'm going to find out what happened to my slope. Now pay attention, my slope. What happened if a is equal to 2? What's my slope? What's my slope? 4. Can you predict what happened at 3? 6, right? Can you predict what happened when a is equal to 4? Can you predict what if a is a negative 1? Negative 2. Look at that, negative 2. What happened at negative 2? It's 2 times whatever x value, whatever a value is. Can we sum up? That's probably 2x. 2x is going to be a good representation of the slope, but we're going to show you how to find it though. So I can find out slope at any points. I got an equation. I'm going to show you what that is. I'm going to show you what if I have a f of x is equal to x squared. Okay, and we're going to use the definition of derivative. Use the definition of derivative. And what is definition of derivative? Is m of tangent is equal to limits as h approach 0. H becomes 0. That's the only thing difference. F of x plus h minus f of x equal to h. So that means what's m of tangent? We call it m of tangent. The slope of tangent is called f prime. Do you see that prime? That prime is called derivative. This is the first time you're seeing derivative, that's what you're going to be learning all year. You learned derivative all year? Okay, so now this is the second time you see it, which is good. So then you got limit h approach 0 of f of x plus h minus f of x over h. So this is very important. This is called definition of derivative. Definition of derivative is this. We're going to use this to find it. You actually done this before. Remember that homework with delta x? You asked me what is delta x? That's h. Okay. So here we are using delta x is equal to h. So instead of delta x, we're using h. So then, okay, let's start with the f of x. F of x equal to x squared. What do you think f of x plus h is? What do you think x plus h is? No. If f of x equal to x squared, what's f of x plus h? It's called composite function.
X squared plus h.
No. Good try though.
Would be x plus h squared then?
There we go. You replace this x with whatever inside the parenthesis. I hear you replace the x with the x, which is not, you're not changing. If I have x plus h, you're going to plug in here. So in this case, it's going to be x plus h. And why did he say, I said it wrong the first time? Because he said the first time is x squared plus h. And please, please don't tell me x plus h parentheses squared is equal to x squared plus h squared. something really bad's gonna happen to you, but I'm not gonna tell you because I'm live streaming right now. So don't do that. So what happened is I'm gonna use a definition derivative, which we're using this. So I'm gonna say f prime of x equal to limit h approaches 0. Why is h approaches 0? Because it's gonna be x plus h squared minus x squared over h. Does that make sense? 1 of f of x plus h minus f of x over h. Does that make sense to you guys?
So is the prime meaning something?
Prime means a derivative. That means slope at all points. Okay. So this prime means derivative. Does that make sense? And what you're gonna do is you're gonna say, okay, well, I'm gonna do this. So I'm gonna say limit h approaches 0 will be x squared plus 2hx, because you expand the middle part, plus h squared, because most of the people thought that square is gonna bring in. No, it's not. You gotta make sure you expand it properly, or you just write down x plus h times x plus h. You're gonna get x squared plus 2hx plus h squared h. Can we simplify anything here?
The x squares.
The x squared, good. So let's go away. Are we okay? So that's equal to, ooh, that's equal, son of pineapple. Limit h approaches 0, 2hx plus h squared over h. Are we okay here? What else can I do here? You take a h out. So h over 2x plus h over h. H cancel out. Limit h approaches 0 of 2x plus h. That means you substitute h is 0, so it'll be 2x plus 0. So it's 2x. F prime of x is equal to 2x, which is that's going to tell me slope at any point. Guess what? If I plug in 2, what am I going to get? 2 times 2 is equal to 4. If I plug in 1, it's 2 times 1 is 2. Just like what we did earlier. Just like what do you see on decimal? F prime of 0, that's just going to be 2 times 0 is equal to 0. F prime of 1, negative 1 is going to be 2 times negative 1 equal to negative 2. F prime of negative 2 equal to 2 times negative 2 is equal to negative 4. Guess what? This equation can tell me slope at everywhere, which is super powerful because we're going to go back. We're going to say, hey, what happened is, let's say it's 4. 4 times 2 is 8. See that slope? It's 8. Could be 6, it's 12. Could be negative 1, negative 2. Do you see that? It gives me a slope at every point. Negative 3, it's going to be negative 6. It tells me at every single point, which is that becomes nice. So this becomes the slope at every single moment. It just told me when to stop. I stopped there, 3.75. My slope becomes 7.50. Because 3.75 times 2 is 7.5. If I run it again, and that's a tangent line look like.
So the derivative for f of x equals x squared is 2x.
Exactly.
But for every function, you could plug it into this one formula and find the derivative.
You got it. So what are you going to do? You're going to do the next one. And this one's kind of like your test. So I'm going to do this one. F of x is equal to square root of x. Remember, when you plug in, you have to take the whole x plus h, plug into the square root, not just the x. And you might have to do with the conjugate. You might have to do whatever you're doing before. So yeah. So I'm going to let you do this one. But on my video, I'm going to show as a rabbit. So if you did it right, it's gonna look like this. Remember, you plug in square root of x plus h. Does that make sense? Your square root should not stop just right here. Keep on going because you substitute the whole thing inside the thing. Does that make sense? Minus square root of x. Does that make sense? If I plug in h is 0, then it's gonna be 0 over 0. So that means I have to do the conjugate. Then that's equal to the limit h approach 0, because a minus b, a plus b is going to be x plus h minus x over h times square root of x plus h plus square root of x. Does that make sense? Does that make sense so far or no? Can this x cancel out because x negative x? Can the h cancel out? Left with the 1. So can I say it's limit h approach 0 at 1 over square root of x plus h plus square root of x? H is going to go to 0. So 1 over square root of x plus 0 plus square root of x equal to 1 over 2 square root of x. This becomes f prime of x. Try again. F of x equal to 1 over x. You also did this one before on your test, except it's not x plus 4 this time, it's x plus h. What'd you get, Trim? Trevor? Negative 1 over x squared is correct. Do I need to go over it or no?
I understand like what you're trying to get us to, but I'm having trouble with making just the original equation.
Okay, so limit h approach 0. So f of x is equal to that. What is f of x plus h? It's gonna be 1 over x plus h. Does that make sense? So it'll be 1 over x plus h minus 1 over x over h. If I plug in h is 0, remember your question? Your question, I think the test question, there was a 1 over x plus 4. So what do you need? You need to multiply this side by x over x. Does that make sense? And this one's x plus h over x plus h. And if I do that, it'll be limit approach 0 of x times x plus h over x minus x plus h over h. It's going to be limit as h approach 0, x minus h over x times x plus h. And this is divided by h, so it'll be 1 over h. Am I doing okay? What happened to the x? X minus x cancel out. The negative h and h cancel out becomes negative 1. So it'll be limit h approach 0 of negative 1 over x times x plus h. Now h is going to go to 0, so it'll be negative 1 over x squared. So this one's equal to f prime of x, when f of x is equal to 1 over x. That can tell me slope at any given moment. How much time we have? No time? Huh?
1 minute,
Okay.
class on 7.
Your homework is going to be like this. Just finding derivative using definition of derivatives.